So without further ado, we can kind of get into our first introduction. So Rich, you are the Director of Recreation at UCSD and have been for some time now. I know you have experience in other UC school system universities, as well as other facilities roles, making sure that facilities are safe and healthy for your athletes and students and staff. Just so the audience can kind of get warmed up, do you mind starting out with painting a picture of how COVID-19 impacted the University of California, San Diego at the beginning of last year towards the end of last year?
Yeah, absolutely. Good morning, all. Rich Mylin, Director of Recreation, UC San Diego. I've been here now 5 years. Before that, I was at UCLA for 25 years in a bit of the same type of role. And I can just share with you at UC San Diego, it really started out as how do we keep people safe and what decisions are we going to make around that. And then this university quickly turned it into maybe a living learning lab, in that we really took proactive approaches to keep as much of the university functioning and allowing students to still thrive, but put them in the safest environment possible. So it's kind of ebbed and flowed. I don't think anything during the scientific process is always right, and it's never easy. So we've learned across time about touch point or aerosol or masking, and I think this university just did a really good job and really shared with staff about what those nuances were throughout the process so that we could function at a high level and keep things going. I can share just in my department alone, recreation, about 66 full-time folks. And since March of 20, half of those folks have been working full-time on campus. So remote work was beneficial for some, but there were still functions that we needed to do on campus, and we could do them safely.
Yeah, that's awesome. I think you guys had a lot more ability to keep some students and some staff on campus while still fostering that kind of healthy environment so people could feel safe and they could have some trust there.
Yeah, instead of typically 20 to 22,000 undergrad and grads living on campus, during this last academic year, we were at 8,000, but it still gave those students an on-campus experience and kept them very safe, and we still kept case rates really low.
You actually did, I think you're being a little light here on the kind of what you were able to achieve. So the New York Times actually released a article on the University of California's school system and how they were able to manage COVID-19 in an effective manner. And they actually mentioned that, like you were saying, UCSD was able to keep around 10,000 students on campus. And while doing so, we're able to maintain a transmission rate of below 0.5%. And I thought that was really interesting because the surrounding county areas in San Diego were all above 6% or more in transmission rates. Like what measures did you first implement to start making sure that you kept your transmission rates low?
I think masking and distancing were the key for us. And then managing how, what that distancing meant to learning. And then, I meet with the UC rec directors. We meet monthly, and each school had to manage it a bit differently depending on what county they were in. So, San Diego County had certain parameters, and then the school was able to manage within that. But I think our big thing was masking and distancing. And now that the vaccine is out, the big push is to get vaccinated. And then within that, we're fortunate here in San Diego. So, we built some large outdoor tents, and we could still have an interactive in-person classroom. But because of, airflow, and keeping those spaces, fresh, if you will, it allowed us to do things that, well, to be honest, is why we're, doing the work we are with Claire, trying to turn almost those outdoor environments into our indoor environments and keeping them fresh.
Yeah, I think that's kind of one of the main focal points of all of these kind of reopening plans is making sure that you have kind of the fundamentals down, like distancing, fresh air, utilizing outdoor spaces when you can. There are a couple other things, some additional measures like aggressive testing on different facilities, wastewater and things like that. So I saw that dozens of facilities were tested. And if there was a trace of coronavirus found, students were instructed to get tested right away and things like that. And I know you might have used the California Notify app to track transmissions and infection rates. So
Yeah, our students had access to testing whenever they wanted. We went from a model of handing them out, quickly moved to a vending machine model, and had vending machines strategically placed. We had 12 of them on campus, and that gave students great access. I think our testing rate was right around 80% of folks were testing weekly. Our athletic teams were testing twice a week. And then once they started competing, they were testing 3 times a week. So that is a very good point. On the very front end of this, it would have been masking, distancing, and then allowing everyone access to testing.
Yeah, certainly. I thought those giant tents were definitely a cool use of resources. So you guys really were able to kind of come together and nip this COVID-19 thing in the butt, like from the get-go. Is there anything that you kind of attribute to your preparation success? Was it the team effort? Was it pressure from parents or school board? What do you think was the reason why you guys were able to prepare so well?
I think it's just an attitude on campus. It's a scientific approach to things. Again, my experience at UCLA as compared to UC San Diego, and both are right because both are great universities. But the analogy I would share with folks, when I was at UCLA, we always talked about that UCLA, with its maturity, is more of an aircraft carrier. But once you get it turned, which takes a while, it does and it goes. UC San Diego, I see more as almost a speedboat approach. It's a nimble campus, and I think with that was very quick to react and take a scientific approach with the plan of still being very active within some new parameters.
Definitely advantages to having an agile kind of campus and team. So definitely can see the advantage there. So then kind of something happened. So you guys were able to keep, at least some type of occupancy available until I think around Thanksgiving time. And then you guys had to close most or all of your indoor facilities. What measures have you been taking since the closing to kind of even further prepare for maybe the reopening and future proofing of the facility towards the end of 2021 and beyond?
Again, when this all started, there was a big push about the touch issues. So we spent a lot of time early on trying to figure out how to keep things clean. Now, we know that has changed over the last year, and the touch isn't, as dramatic as we all thought it was a year ago, where you can kick a soccer ball around, or you can lift weights, or you don't really need to wipe down your groceries. Some of those things have just morphed over time, and we've been fortunate on campus to have really good experts kind of lead us through the process, and understanding that, we just learn things as we go through what we're doing together. The biggest thing now is, and what we've been preparing for, and I don't know if we'll get to, but I'll just share now for those on the line, the recreation center that is one of the buildings that recreation manages became the mass vaccination site for the university and for the county. And we were doing about 4,500 a day. So back to the question that's in chat, filtration became a big conversation because that seemed to be, for most of our experts on campus, the way to keep the indoor space and get it open quicker and allow the vaccination site to be as safe as possible. So then it became the conversation of, are you doing 8s? Are you doing 11s? Are you doing 13s? How often are you changing them? We not unfortunately, we just didn't have time to really do any air exchange testing, but we knew the building functioned well before. So that's how we're preparing now. It's really about, what are your filtration? How often are you changing them? How efficient, making sure all your VAVs are working well and that your boxes are moving air. And that's what our campus is really pushing us on. And then the benefit is, shoot, Ellie, what is this now? I think we've known each other and been talking about this type of work. It's probably 6 or 7 years now, because it started when I was at UCLA. That, in my environment, the air is a competitive advantage. And we need our athletic and rec spaces to put people in the healthiest space possible. So I think I'm most excited that, along with some things campus are doing because of this partnership and because of the working with Ellie and the team, recreation, and then therefore the athletic department who works with us, are going to be that much farther ahead, I think, to put students in the healthiest environment to perform.
Definitely a lot of focus on having clean air through filtration, making sure that the athletic facilities are all kind of doing the most they can to create like a healthy space for the athletes. I think this next slide might also kind of jog some of your memory on some of the new projects you might be working on. I know you're working on filtration and outdoor instruction, things like that. Could you touch on any of the kind of new technologies you're using as you're looking to reopen?
Well, when it gets to the technology behind it, this is my favorite part about a good partnership. I get to talk to experts like Ellie, who then share with us what we need. So I would actually defer this question. I may, as a director, just so everybody's aware, I listen to the experts, I listen to my staff, and then I try to create the resource so they can succeed. On this one, it was important to me, again, I think it was 7 years ago at UCLA. Quick story, we have a gymnastics training area that is always full of chalk. And no matter what you do, and no matter how many filters you throw at it, those athletes, aren't in the top end performance environment. And UCLA has a national championship gymnastics team. So in working with ionization and then monitoring with Claire, now we know what we can do and how we can put our athletes in the best position. In moving to UC San Diego, I wanted to bring that technology with me, but by no means am I the expert in the technology. So I'm just excited to have the information, especially at UC San Diego, that is so data driven. I think this is just going to help us across so many different avenues. And with anything I do at a university, I'm hopeful to tie it back to some academic endeavor as part of the overall learning that takes place at a university.
100%. Yeah, I was actually just about to bring in Ellie here. See, I know Rich kind of spearheaded this whole project here, but I know you and your team are maybe the brains behind what's actually going in here. So do you mind kind of explaining what the process of implementing, needlepoint bipolar ionization and indoor air quality monitoring in UCSD kind of looks like, and what the reasoning behind all of this was? And also welcome Ellie too, by the way.
Thank you, Harry. Thank you, Rich. Just to mention one point regarding the collaboration with UCSD, it was actually one of the greatest partnership that we had with them. It was very good to work with the team and with Rich, because they were willing to listen. And we learned a lot from them as well. We come on the technology side and we go in the field, and as long as you don't have the experts from those fields that they are on their day-to-day business, they're working with the clean air management inside the building, we wouldn't be able to provide right information. So I'm very pleased and honored to work with UCSD and looking forward to expand that. Well, I will take a little bit step backward and explain why Claire actually started and why we started talking to partners like UCSD or other universities and organizations. I always use this analogy that if you're not feeling good, if you feel there's something wrong with you, you will go to a doctor. And what doctor does, they will talk to you to understand where you feel the pain. And then they will write some tests to actually look at parameters and markers that can actually cause those pains. And then after looking at those data and as those test results, they will decide what to prescribe. And then when you actually get that prescription, they will test you again to make sure that pain is gone. I mean, they talk to you, of course, but they make sure that the markers or parameters or factors that cause the pain is gone as well. It's the same for buildings. It's the same for air quality. So if there is something wrong with the air quality, if the building is hurting in its pain point, and that pain point can be low performance, for example, or low productivity of athletes or students or staff, it can be in this situation, unfortunately, the COVID problem, and it can be like, other examples like stuffiness of the air, complaint regarding the air quality, mold inside the building. A lot of things can be actually that pain of the building. What they call it sick building syndrome is a real term. So when you look at that, instead of jumping on a prescription without knowing what is causing that pain, it feels like you go to a doctor and the doctor, without talking to you and testing you, just write you a prescription and tell you go and use this. That can be a disaster for a human being. That can be a disaster for the building as well. Sometimes we kind of get some extra costs and we have to pay something extra because we didn't take this step at the beginning and collecting the right data and doing the right testing to be able to find the right solution for the building. So this is where Claire started. Claire actually started with looking at those, hearing those pain points from the building and say, okay, what can we do to actually do the testing, do the right testing? There are air quality testing, which they're great. They're like, these on-spot measurements with the handheld probes, very accurate, no problem with that. But we always say, like, if you're measuring this spot, it might not show you the whole building feeling, or it cannot maybe represent the week or a month or what's going on inside the building. That's why we came up with the continuous monitoring, indoor and outdoor air quality, as well as the HVAC system, how the filtration is working on. Are you completely blocking the pollution coming from outside to inside? Is your filter sealed properly? Is the pollution coming, is it generated inside? As Rich actually made the example, if you have a space like the gymnasium that there's a lot of trucks and there's a lot of particles in the air, doesn't matter how much fresh air you pump in there, and how much filter you might be exhausting your ventilation system. What is the extra step that you can take to reduce this problem inside the building and improve the air quality for the purpose of the higher productivity, for the purpose of the health of the occupants and the tenants of that building, and in this case, to reduce the risk of airborne infection? So I talked a lot, and I thought that to set the stage in this way, kind of telling the story, but I'll be happy to answer more questions.
Yeah, great. So really it's about implementing continuous indoor air quality monitoring to kind of get a pulse on the health of the building, identify any of those pains that you were talking about. And in doing that, you're able to kind of prescribe whatever the solution may be for the given problem at hand.
Absolutely.
I just wanted to bring it back quickly to Rich. So I know you guys had like you had mentioned before, kind of took on an exciting role recently or an honorable role as a COVID-19 testing and vaccination center. What do you think made UCSD kind of an attractive choice in deciding on a vaccination testing center?
So the process played out. Our UC Health, that just across the freeway from us, that's part of the university. They first opened a mass vaccination site outdoors. Again, this was back when we're still learning about the virus. So indoor wasn't even an option. So they did an outdoor, you drove in, shot in your arm, pulled into a parking lot down near Petco Park, and they were doing 3,000 to 4,000, 5,000 a day down there. As we got closer to baseball season, everyone knew we were going to have to move out of that opportunity, and they began exploring throughout the county different places, how people would travel, how they would park, and you just went through the logistics. Like you almost treated it maybe like a Super Bowl without the security, but you really tried to walk through what your fan experience would look like. It came down to REMAC because it had so many different great options to lay out the different rooms that we have, and a couple of our rooms had really big volume and the opportunity to open some doors for outside air, and that made some folks comfortable. Then they did review actually taking a parking structure and doing it that way, so it was more of an outdoor environment that was still covered. But in the end, the experts were happy with what we had in the building. They were happy about how the large volumes of space, what our airflow looked like. And then again, we had just installed the Claire monitors because again, UC San Diego Rec did not create this conversation about air quality because of COVID. Mm-hmm. It's just turned out that the conversation about air quality is even more important now that we're doing it. But again, our focus from the beginning was about performance and keeping people healthy and active in the building where people are trying to be healthy and active. On that end, they were excited to know that we could tell them CO2 levels at any time during the process, which again goes back to our focus on this campus of being data driven in the work that we do. So in the end, they chose that it would be a better customer environment and it would still be a very safe customer environment to use our recreation center as a vaccination site. And then I can share overall, we had one incident of a COVID test that came back positive. It was from a volunteer, and we're still I can't say we're 100% sure if they brought it with them or if they got it from the building, but we did a level 4 cleaning. Being more of a hospital building now, once health took it over, we didn't evacuate, we didn't need to close it, but just to be transparent, that in all of it, we've been open since early February. I can share this now because it just got announced. We've been talking with them. We are closing on June 1st. We had planned to be open until September 10th, but the amount of vaccine that's gone out because of this site has given San Diego County some comfortability. And then, we've also known that there are some folks out there that might not take the vaccination. So everyone feels comfortable. We've hit a good number and we're not getting as many signups. So we'll be closing the site on June 1st. And then I'll just say, because of the monitoring that we do have, I'm just peeking at the Q&A. I'll answer that third question that just came in. We have not found any ozone issues at this time. And it's not really a but, it's and in having these conversations with lots of different people, including Ellie, over these last 7 years, it's why I do find it important that if you are going to do something to play with the air, and everything we do is a game. So for us, that ionization is something we're gamifying, keeping it clean. I think pairing it with a good monitoring system, which for us is absolutely why we're partnered with Ellie and the team, then we know what we're doing, and then we can make adjustments like a coach would in a game. So just to answer number 3, we have not found any issue, and I think that's why we want to make sure our monitoring is the best it can be, so we can make sure that we are putting everyone in the healthiest environment possible.
Yeah, absolutely. I think just for anybody wondering, that question came from Mr. Barnhart, and that was if Rich had been seeing any problems with ozone from needlepoint bipolar ionization. And it does not appear to be the case at the moment. And I know that you're monitoring the progress day by day, minute by minute. So
I I have to jump in here.
Yeah.
I'm putting my technical hat in there just to make a little correction. And it's not to Rich, it's just in general. The pipeline ionization is the technology. There's two separate technology. There's one needle point and there's one like these tube based. So when we're talking about the bipolar ionization, let's talk about the bipolar ionization, because these are like kind of detailed into the technology, and it might be the one that UCSD is using might be different than one that another organization might use. So just making sure that we use the right term of just the bipolar ionization rather than pinpointing to a specific technology that's in that environment.
Gotcha. Yeah.
Okay. Sorry, I had to, my engineering part cannot,
Yep.
couldn't stop.
My favorite part of working with you. So yes,
Thank you.
keep me in my lane, please.
So, Rich, you've kind of been the man of the hour here so far. I just wanted to end off with a kind of one final question before diving a little bit deeper with Ellie here. What does UCSD's future look like right now? Is there any kind of long-term goals or initiatives that you see coming up over the next couple of years?
Right now, we plan to be full back with 20,000 plus students on campus come September. All of our athletic programming up and running. Now that we know that the vaccination site is closing earlier, we hope to have the recreation center open sometime in July. The students were actually behind this also. We took it to our board. Students voted unanimously to use the rec center as a vaccination site, and they voted until September 10th, knowing that they would like it back open for school. So now that we know we can open earlier, we're going to try to get that open. And then at the same time, campus is still booming, lots of construction. I can't say for sure, but I do know a lot of the project managers and architects, that work on our campus, and air quality is only going to become something more in these conversations, knowing how the kind of that aerosol virus is being managed. So I don't know for sure what the future holds, but I know the future holds more buildings. And at least in recreation's mind, we hopefully will have one new and a very large renovation of an older building. We hope to do that between now and 2028. And I know as long as I'm working here, how the building functions indoors and as for air quality is going to be something I'll push my architect and engineers on any project I have to make sure they can really deliver a really healthy building.
Awesome. Yeah, I think you guys are on a great start towards that. A lot of great things going on. So I definitely appreciate that, Rich. But I kind of wanted to shift the focus now over to Ellie so we can kind of discuss a little bit more on the technicalities and things to consider about indoor air, indoor health during COVID-19 and beyond. Ellie, could we kind of start out with what is all the buzz around indoor air quality and COVID-19? Why is this such a big topic right now?
So I think at the beginning of the COVID era, it was identified as a virus, and they were looking at modes of transmission. Definitely, it was something that was affecting the breathing system and respiratory system. So at the beginning, they started saying, well, it can actually, if you touch surfaces and the virus is in there and you basically kind of get it around your face, you can breathe it and go to your lungs. The other mode of transmission was this close contacts that you're speaking or singing or you're very close, and these big droplets as we're sneezing or talking, we're always emitting some droplets outside, or also when we are kind of exhaling the air that we breathe, it can come. And then if you're close enough, these big droplets will not drop or will not go in the air or get filtered, so it can actually rebreathe that, and then it can go in your lungs and affects that. So that's why you wear mask, and that was the recommendation, to wear mask at all time. As this study was going on, a lot of research has been done in the areas that was COVID outbreaks, and looking at the effect of ventilation system on those areas that had COVID outbreak. And they realized that I think around the time frame of July or August last year that CDC and WHO came back and said this virus is airborne. And by airborne, what it means that the virus can linger around the air for a longer amount of time in a smaller particle size, and it can actually stay around for more than 30 minutes. And then if somebody passes and you don't have proper ventilation or fresh air or all those measures that needs to be done for cleaning the air, not only cleaning the surfaces, but cleaning the air, the second person that's passing by actually might be exposed to that virus and catch it. And therefore, there will be kind of a problem for that. So that's why they started looking at, okay, so when it comes something that's called or categorized that as a virus that can be airborne transmitted and can cause infection through airborne transmission, this is where the air quality becomes very important. And you're looking at the parameters that affects on these airborne transmission. For this, you really need to look at how this virus survive in longer time, which for COVID-19 is kind of humidity that allows this, with the lower humidity and colder weather, it allows this virus to survive longer. It looks at how it actually carries out and kind of travel through the air, which it can actually stick to particle size, small particles, just stay in the air or move around before just dropping on the ground or kind of sticking somewhere. And the other one is if you have too many of these virus in a volume air and you are in there, you for getting infected, you need a specific amount of a number of viruses in your body to actually get infected, and your body kind of cannot fight it back. So if you don't have enough fresh air and you have concentrated viruses in the volume of air, the chance and the risk that you get infected is higher. So how do you measure the fresh air, amount of fresh air in your building? Is with the CO2 level, because that's the only one that it tells you, is the air old and breathe it and rebreathe it from other people, or you have enough fresh air from outside, which you have enough oxygen level so you don't have concentrated virus level inside the building. So I think I went a little bit ahead of my myself, but that's what explanation was for why air quality is so important in the COVID era, because of being airborne transmitted and the parameters that it affects for the virus to survive longer and travel longer distance.
Gotcha. Yeah. So you mentioned a couple kind of key things there. One thing you had mentioned is ventilation and CO2 rates and things like that. Can you kind of walk us through what ventilation might have looked like before COVID-19 versus after?
Sure. I mean, it depends building to building, but before the COVID-19, the focus was mainly to keep the comfort and also the productivity of the tenants and occupants and students. And also another important thing was the energy saving, because the HVAC system and the ventilation system is the biggest consumer of the energy. So when you're focusing on that, the settings inside your building is going to be a little different. You kind of look into an optimum level that you have minimum energy costs as well as the highest productivity when they meet somewhere. So the level of fresh air inside the building per person for a setup of an air handling unit might have been a little bit different. So 2 to 3 air exchange per hour was something that was kind of noted as a normal. The recommendation for high productivity areas was 6 air exchange per hour for hospital locations, up to 12. These are coming from ASHRAE standard. Then after the COVID era, the requirement changed a little bit because they wanted to make sure that the amount of fresh air per people or per person inside the building is higher than what it was before. So that's why the requirement from the healthy buildings came up to increase the air exchange per hour to almost 6, or reduce the number of people inside the building.
Got it. Yeah. So before the pandemic, wasn't as much of a concern to really look into these air exchange rates and CO2 levels. But now, as transmission's a bit more concerned, we're really trying to make sure that if we are going to have people in a space, that it's properly ventilated. And if that can't be the case, then we have to reduce the number of occupants in those spaces. You also mentioned that particulates could be a point of concern for transmission, exacerbating transmission or kind of acting as a vector of sorts. Could you speak more into that?
Sure. As I mentioned, the viruses can either come out of in a form of nuclei, so they're in like water droplets that are exhaled from an infected person, or it can use dust and particle as a carrier to wander around and stay in the air. So with that said, when you have higher particle or dust level in a space, you will have higher chance of getting infected because the existence of the virus is higher in there. So there was a research study and some conclusion from Harvard School of Public Health that mentioned the relationship between particulate matter of certain size or dust level of certain size, which is 2.5 micron, to the rate of infection and even death risk of that. That's why there is a threshold put as a 10 microgram per cubic meter for the particle level inside the building. To mitigate that, the solution was to have better filtration, improve the filtration, making sure that the outdoor pollution is not finding its way inside and creating an environment for the virus to stay longer.
Got it. Yeah, that makes a lot of sense. And the other thing that you had mentioned was that relative humidity had been a factor. It should be kept between 40 and 70% to reduce that increase in risk. So,
yeah. So for specifically COVID-19, lower than 20 or 30% is dangerous because that virus can survive longer. But if you go more than 70 or 80, you're risking your building to have like mold problem. And there are other type of viruses who can survive in a higher humidity area. That's why, in general, for a healthy building, they recommend to keep the humidity between 40 to 60 to 70%.
Gotcha. Great. Just for anybody that's looking into kind of indoor air quality management, monitoring, things like that, is there anything specific that they should kind of start with when they're looking into it?
In terms of parameter or like a solution?
I think maybe that might be the answer there, is kind of beginning with what you want to measure to begin with, or what is your goal?
Yeah, so that's where I don't want to put ourselves like a doctor of the building, but I will go back to my doctor and patient analogy. When you actually have a pain point and you feel like there is something wrong with your building, or there is a goal to achieve, for example, is it energy saving, is it lower risk and healthy building, is it like, anything that you want to achieve, we can be there and talk to the customer. There is not only us, there's so many indoor air quality experts that you can reach out to and talk to them, and then tell what is the thing you want to achieve or what is your pain point, and then we can direct you to what is the right parameter to measure, and we can direct you what is the right solution to use. These are the parameters that are currently the most important one to take a look at within a building in terms of air quality parameters, but I will not pinpoint or specify a one to this right now, because depends on your goal, depends on the building usage, and then we can actually say, here it is what you need to measure.
I guess it really just matters that you start measuring something that will help you make a data-supported decision towards your goal.
Absolutely.
What
I would recommend is to make sure that you do there you go. You just brought it up. I've not seen these slides, so it's just really cool to do actually continuous monitoring, because continuous monitoring can give you the option to identify the trends, being able to predict some of the events, identify some abnormality or spikes, or prevent something before it becomes an issue.
Mhm.
So when something is like a problem is kind of rising, you can detect it at early stage. It's like a disease or sickness that you can, if you detect it earlier, the cost of mitigation is much lower than if you detect it later.
Gotcha. And so what kind of equipment would you need for this continuous monitoring?
So there are devices for continuous monitoring that the UCSD right now is using our solution. I don't call them air quality sensors because the sensors are these little modules, and then you have the air quality monitors, which measure different parameters at once, which this give you kind of a visibility of all of these also are related, the CO2 level and particulate matter and VOC. These are kind of related. So if you have a certified monitor that provide accurate enough data that you can rely on, then you can look at the trend, you can look at the spikes, abnormality. We or any air quality expert can help you using those data and make some decisions.
Gotcha. Yeah, great. So then just one before we kind of get into some of these Q&As, what does a successful IAQ management plan from start to finish, what does that entail?
Well, basically, as you're showing it here, we would like to go with making data-driven decisions. So collecting right data is very important. Air quality data is not the only one that does matter for that. Your building is your asset, and it creates a lot of data. It generates data on a daily basis. Your HVAC system is generating data. Your building, your occupants, they're walking, their behavior, creating a lot of valuable data. That is not really dealing or doing anything with the privacy or concern of that. It's just related to what you can use as the air quality. So the first step is really to collect enough data and the right data that you can analyze. The second step is really to analyze it, making sense out of those data. With the digitalization era right now and everything being disrupted by machine learning and artificial intelligence, self-driving cars, why can't a building be a self-driving building or a self-sustaining and taken care of building, So if you have a trusted partner that can bring right solution and devices to collect the right data, and as we have it in our team as well, and working with the team in different universities, specifically at UC San Diego, a team of data scientists and experts in air quality management analyze those data and then make sense out of it, you can pinpoint exactly where the problem is, why this problem is happening, and then you can make the informed decision. That decision can be as free as opening your window or closing the dampers or opening the dampers. It might not be like an expensive solution that you have to turn down the building, and it might go there if you have too big a problem, but at least you know that you made an informed decision, and after you implement it, you don't scratch your head and it's like, is that right or not? But then when after that is done, you have to make sure that your solution that you actually put in place was effective and it's doing what it's doing. It's the same as the doctor analogy. After they give you the prescription, they tell you, go and use this drug for 6 months, come back, we do another testing to make sure that everything is in place and everything is good. That's what we need to do. And for the air quality, sometimes you see immediate effect. We had customers, we have clients who they actually saw immediate effect and improvement in the air quality, and that is very important. But you also have a goal of long term. You want to keep your building healthy as you want to keep your body healthy. So there is a healthy baseline that can be defined for your building, and use that threshold by continuous monitoring, making sure you're always staying below that threshold. And if you're getting close to that threshold or it's like a little bit higher, you can detect it as early as possible and mitigate it as fast as possible. So your cost of maintenance, I would say it, cost of reactive maintenance will go drastically down.
Gotcha. Yeah. So like bringing it back to kind of this first point in our discussion is that what gets measured gets managed. So as long as you're collecting the accurate data and you're making improvements based on that data, you're definitely liable to see a lot of long-term benefits in terms of indoor health, efficiency, like you were mentioning, maintenance procedures, things like that. So there are a lot of benefits to clean air in 2021. So kind of want to end off here. I think from our conversation, it's pretty clear that clean air can help reduce COVID-19 risk of airborne or aerosol transmission, can help you save on operational costs, increase energy efficiency, and also boost performance, which is especially important for universities right now.